All right, so we're going to be looking at my electromagnetic rotor, and we're going to be looking at my, well, different coils and how they interact with the reed switch and how they interact with the transistor. So stay tuned. Hello, hello. Setting up the tripod. Did a cameo thing. Whole spiel. We're going to be testing reed switches and transistors and the difference between the two, and the electromagnetic rotor that I'm working on. It's almost done. I just got one more coil to wind. Check this out, man. This is going to be smooth with the reed switches going across right here just above. Oh, it's going to be great. Maybe off to the side a little bit. We'll find out what the good position is. But each coil is going to get a reed switch. That's going to be awesome. Okay, so right here I got my 120, my 3 magnets. Sometimes it's going to get stuck. You can unjam it by putting more voltage in, or in some cases less voltage. Moving it closer to the magnets. Another way to unjam it, by force, magnetic force. So this coil, see, all I had to do was do that, and it was enough to if you noticed, it might have switched directions too when I was flicking it. So see, I moved it a little bit closer, and that magnetic force can like force it open or closed or whatever. It's forced or it's fused closed, so it gets forced open. A couple flicks and we're off to the races again. That's awesome. So we're putting 9 volts in because I'm planning on using 9-volt batteries for the setup. The setup is 3 coils in the center rotor with 9-volt battery for each one. And we should really hook these coils up to this and see if it can't run. I don't think it'll run well, except at really low voltage. And then it'll run well at low voltage. So maybe not a 9-volt, but like a 3-volt lithium ion, same type, but one of those little 3-volt ones. I don't know, we'll see how it runs. I got a DC power supply, so we can start low and go up, but I've only got one reed switch right now. The rest will be here on Tuesday, but it works. The reed switch works. This is a great little test spot to test out the coils. And that's why I'm being so aggressive with the switch, because it's like, don't break down on me. Don't do it. All right. Let me get one of those coils out. Of its harness. And I gotta roll one more of these. This is 4 layers of 20 gauge. There and back and there and back. The first 3 layers are always pretty nice, but then the last layer, I don't know what happens. I just want to get done with it by that point. Because I roll them by hand. Some I roll by machine, but some I roll by hand. And I think it's because the cores got stuck, but they're stuck in the perfect position. So I'm not gonna mess with that. I'll just roll them by hand. And put it on this little block. And then we got my little apparatus here, my little 3-way clip. Got a diode going this way, a diode going this way, and it'll hook to the end of the coil. Like so. And then both of those diodes are connected to the reed switch. Just need to seal the deal with a little bit of glue. This should be interesting. I haven't done it with a real reed switch yet. I did it with my my homemade switch. It was pretty good. But I don't know. We'll see what's up. Hope it doesn't fry. Because then we'd be down to transistors, but those aren't too bad, right? did something not quite right. Well, that's a lot of amps. You see that reed switch? Holy smoke. Hope it's not perma-fused. There we go. So we're at 1.1 volts. Something tells me it wants to maybe go the other way. I don't know. No. Yeah, I thought this would be a problem. It being so small. So I think, you know what I'm going to do is I'm going to wrap 32 gauge around the outside. And we're going to run it in series. That's what I have for a plan. Oh, it's broken. Haha. Okay. I flicked it too hard. All right. So, yeah, that sucks. Well, I mean, it's not really a problem actually. What sucks is the reed switch is dead. That's what sucks. But it won't take but a second to get back on track here. guess we're gonna hook up the pot. Yes, sir. Hooking it up. Make sure this is all hooked up right. Except for this. You know what, we're gonna pull that off for a minute. Wow, 7 amps. Holy cow. That's really high. It's only 4 volts. Something's not right. It's probably the transistor's blown already. All right, I got one of those. All right, let's see. Let me just try something real quick. Even though. Where did I put that? There it is. Boom. second. This out. There it is. See, there's something about that pot that might not be right. Let me get the camera real quick. Yeah, I don't have vids on chat, so I'm gonna carry this around with me. Bear with me. Yeah, the 120 degrees. This spot right here is real, yeah. I guess. I mean, it's yeah, it's worked before. But I put a non-variable resistor in its place. So now I have two resistors going. I got a 460 ohms and I believe that's a 230 ohms. It's a whatchamacallit, ceramic bearing. I don't know. Yeah. Are you talking about the optics on the rotor? This the way that it's built, man, it can't go that fast. It's not designed to go that fast. But it goes all right. It's pretty all right, man. This is what we're putting into it right now. 5 volts, 6 volts, and 300 milliamps. It's a 16 gauge coil with 26 gauge trigger strand. That right there is a 12,000 turn 32 gauge coil. Yeah, that was kind of the idea. Have it like when it spins real fast, it looked like. See, look, just the shaft right now is starting to shake. And it's a 12 volt system, so I mean, well, maybe not this coil, but the circuit board is definitely a 12 volt system. I am the landlord. No, sir. This is the motor right here. This and the coil and the power, which is now off. Now it's running on its flywheel capabilities. I put a lot of weight on the edge, so it'll spin for a while. And with this coil up close, it'll charge a battery just from the residual spin. Thank you. Appreciate you. Hello, hello. Now, if I can look under here for a second with you guys, you can see that it's resting on two toroidal ferrite magnets. One on the rotor and then one on the table. Yeah. I mean, the ceramic bearing does help out a lot. It will eventually stop, but I mean, it spins for a while. It's only 8 inches, so it's not like a standard flywheel. But it's 100% in the PLA print, and the neodymium magnets at about 1.5 pounds. You can see it real good now. It's like slowing down enough so you can see it. That's sweet. That spiral right there is pretty bad. No, sir. It's a K Energy SSG circuit. It's a pulse motor. SSG. It's run by SSG. It's a bifilar coil with 16 and 26 gauge. Currently the power is off. Well, I mean, I do have something to that effect that I'm working on. It's right here. So all the electromagnets are going to go on the rotor in the middle. And then I'm going to have a 180-degree magnet spread, neodymium or ferrite, on the outer edge. It's going to be run on reed switches and batteries. It's going to be pretty awesome. No, I've been studying more how to use them, but I don't use them. It's more or less because I don't want to learn a language right now. But I will eventually get bored and want to learn that language. It's pretty logical, so it's going to be easy for me to do. But I haven't done it yet, so I don't. But that sounds like it would be pretty awesome to use an Arduino on that other rotor that I'm building, because it's going to run on 9 volts. Awesome. I'll check it out. Because, yeah, I think an Arduino, at least a 555, if not an Arduino, for the timing on that one. But it's going to be run by reed switches. But I got Arduino reed switches in the back here, so that'll be all right. Oh man, I saw a great presentation on dark matter. and dark energy and how they work together. But there's two totally different things. Very portable coil. This coil is, it fried my reed switch. So I don't know. I think I'm going to have to wrap 32 gauge around the outside nice and tight, like 4 layers. And that'll save the reed switch and give a little bit more magnetic field. So yeah, that'll be what I need to do with this. No, I know that dark matter plays a part in how the universe expands. And maybe it's just that the universe is bigger than we think it is. I can't believe it's still spinning that fast. That's amazing. The power is still off. That is freaking dope. Yes. The carbon, it's 1018 carbon steel, surrounded by 4 layers of 20 gauge. It's 3 inches long and 3/4 inches in diameter. And this one is 4 ferrite rods. They're 2 inches long and 3/8 of an inch in diameter. I shoved 4 of them in there. They're all isolated too. It's pretty nice. But I mean, I'm proud of it. And there's a word for what's going on here where I'm from, and it's called ghetto. It's pretty nice though. I think it's a high level ghetto setup. I hope that helps my throat. That water. Oh wow. All right, I think it's slow enough to start it up again. All right, so what are we worried about? Free energy. It's already free, dude. All right, here. This is what it is. It's 3 1/4 inch carbon steel with a PLA wrapping. It's about 1/8 of an inch total. So 1/16 of an inch length, diameter, whatever that would be considered. And then you wrap 4 layers of, and you tape each layer to try to get uniformity. Aha. So Uniformity is an attempt because, you know, I'm wrapping them by hand. And by the time I'm done wrapping them, with how little the coil is and how big my hand is, my thumb is like in a locked position. Yeah, man, because you try to make it uniform, so you grab it really tight and you try to keep everything nice and tight. One more to go, and that's right here. And then I think I'm going to wrap 32 gauge around the outside and combine them in series. And that way the 32 gauge will act as a resistor and it'll give a little bit more magnetic field. Those are wound counterclockwise. So I believe they're north facing out, the way I have it set up. So 5.9 or 6 volts give us that much output on the light. That's a lot for 6 volts. I mean, the system isn't really supposed to even work below 12, 10, 12 volts. But the coil here is 16 gauge. So we're getting a lot of power off of this system. Of both, we're getting the output over here and we're getting the mechanical up here. That's a 9 magnet rotor. And it's whipping for 9, dude. That's awesome. And it's going to keep on building up in speed up until its potential at 6 volts. Woo! That's going pretty fast. Oh, that is so cool. Mm. What experiment? What guy? What are you trying to say? mm. This is terrorism, right? What you're doing right now is terrorism. All right. So yeah, thanks for the distraction, but I mean, back to the lecture at hand. So this is physics 108. You put a big heavy disc on a stick and you spin it really fast, it's going to keep spinning. Okay, there's nothing magical about it. It's pretty cool though. I mean, it's not that it isn't cool. I think flywheel application is great. But yeah, as for it being anything like that, it just isn't. Not after the last year. Nothing like that's going to happen. So just for what? Now I'm confused. But thank you. Uh, yeah, I don't know. There's lots of things that I find really interesting about this in this field. The pulse motor stuff is what I do. I do it basically because it's easy. It's the most simple circuit you can do is a pulse motor circuit. You got your coil, you got your switch, and you got your power supply, and that is basically it. And it functions beautifully. And then you got to put it up against a rotor. So I guess the rotor is part of the circuit, but not essentially. It's something totally different, especially on a brushless motor. It's a separate entity. It is not in contact with any other part of the motor. But, at the same time, through various laws and principle, the rotor is essentially part of the motor, even though it's not contacting any other part except the shaft. Okay, the shaft and the rotor go together, but they're separate. But at the same time, it's like synchronized. So you can't have one without the other. But through the same contactless principles, you can generate enough electricity to charge this battery just from the wheel spinning. Now, granted, you're gonna generate something like a lens um, law, and your rotor is gonna slow down less gradually than it would if the coil wasn't there generating AC. And it's this coil right here that's just its sole purpose is to generate AC electricity off of this wheel. It doesn't do anything else. That's all it does. I have not tried to um well, I wouldn't say that. I would say that I've tried with the knowledge that it wasn't going to happen. So basically what I was trying to do was see how far I could get the wheel to spin without having to spin it again. That was the premise that I went forward on. How far can I get it to spin without having to spin it again? And that's exactly how I would say it in any situation. And I'm telling you, man, it's power's off. So that's when I say flywheel application, it's definitely a flywheel. I mean, it's not the heaviest thing in the world, but it's balancing on a magnet. Um, and yeah, I think it'll spin like this for another 10 minutes, maybe more. And it's got two coils up against it right now. That's freaking cool, man. That is, I always like this rotor. So this is a total of about 670 ohms of resistance on this SSG right now. And it could get more, it could do more. But, and something's not right with the pot. It's not working correctly, so I'm not going to use it. And I only have one, so it's, and it cost me $25, so, you know, I'm not in the mood. Heck yeah, man. I love this coil, though. It's so powerful. Because we're already drawing like max amps for a good setup at like 300 milliamps. And we're only at 6 volts. Look at this. Like if I did the math for the power, uh, God, it's still like 2 watts kind of. There's another rotor I want to try though. It's a 2 magnet rotor. We'll go from 9 to 2. Now the two magnet rotor is a lot lighter. Yeah, I used to do permanent magnet experiments at the beginning of what I've been doing. And there's the 2 magnet rotor right there. Oh, I just love that I can do that with one hand on a 1/4 inch hole, man. That's pretty good for somebody who shakes as much as I do. All right. Still can't get the soldering down because I shake so much. But I got a gun and I've been practicing, so I'll find a way, man. I'll like hold my arm with the other arm and get a clamp set and try and do something. No, but I think Oh, well, that's still the same. I think that I've seen some pretty cool perpetual machines using permanent magnets. Oh, look at how low the amp draw has gone. Well, it dips down to below 100, man. That's pretty sweet. So I got the same permanent magnet levitation going on here that I did with the other one. You can kind of see it better because it's so light. And how do I center those on a 1/4 inch pole? I use this. Twelve volts in. Look at that output. Holy smoke. With the 2 magnets, that's pretty awesome. Heck yeah. Wow, that's moving really, really smooth. All right, I'm gonna go get my tack meter because that's gonna make things a little bit more interesting. I have to put this up on here though. All right. No, I think this rotor is getting up to max speed like a lot faster than the other one was. It might be there already. So like 1500. 1450. Oh, I don't play games, dude. And it's so a thing, dude. It is a thing because let me just explain to you how I saw it in action. The magnet popped out of the rotor and it went this way. Okay? The rotor and the shaft went that way. 180 degrees, man. The equal and opposite reaction stuff. I'm not trying to say anything about the laws of physics, really. All I'm trying to say is my opinion is they may be incomplete, I'm not trying to disregard anything that we know. I'm just saying maybe there's some stuff that we don't know. That's my opinion on that. And now my pulse motors have nothing to do with that. You want to talk physics? Go take a physics class. If you know physics, that's cool. I don't even know what you're talking about. Right now, I'm not even measuring the output power. I could hook that up. See, you're assuming that I'm even doing that. The layer, let's do this. I guess I'm supposed to be doing that. That would make sense why people would be saying that. The output power is going to be virtually nil on the output side of the SSG because it's a 12-volt system. I mean, that is just the way things are, but I can get lots of mechanical power. I can hook up my coil. As a matter of fact, that's what I'm going to do. I'm going to hook up my pickup coil, and I'm going to measure that. Now, I'm measuring the input by the power supply. That's how I'm measuring input. We're going to get an AC reading and a DC reading off the same coil. So 13 volts AC are coming off of it just from that with 2 magnets. All right, so we're going to hook up the other multimeter to the DC output. Where is it? Right here. Oh, man. I don't know, man. I'm starting to see like bridges being built that aren't long enough to transcend the water. So let's see what we get. Wow. And that's because we are getting the DC reading off of this filter right here. So 7.4. Wow, dude, that is freaking amazing. But it's because there's caps in it and they're being stored. So, I mean, the output, I'm still not measuring the SSG output. This is a separate output that I get from having a pickup coil on the rotor. Currently, we're getting like 20 volts off the coil and I don't know, 35 volts off of the DC apparatus. Oh, I'm not even discussing losses and gains, bro. I'm just, what you see is what you get. Okay? I'm not talking any mystical power that you can't see. You know, everything that's happening, you can see it right here. I'm not changing. I'm not joshing. I'm not lying to you. Okay? And I'm not saying that there's any gains or losses. I'm not talking about gains and losses. I don't care. Okay? Literally, I am talking about what is on the meter right now. AC volts coming off of the pickup coil are 40 volts. DC coming off of this thing right here, 70 volts. Because it stores a little bit in the caps. Now, I'm not trying to say that I'm right here. This is what we're putting in. 12 DC volts, 300 milliamps. And what you see is what you get. And listen, man, it would say Papa Bale's free energy if I was talking about free energy or gains and losses. I'm talking about pulse motors, man. Now, on the offhand that these pulse motors do some of that stuff, what you see is what you get. It's simple. But what he's saying is true, whether he's here or not still. I mean, I get passionate about it. I'm not upset. I hope you guys are not upset. I'm just passionate about, this stuff, and I'm not trying to sell you anything. You got two magnets on the rotor, so you got pulse and the light. It's simple. It's awesome. Now, as for, I'd say there's probably a minor loss, even with the coil on the wheel, because the coil is slowing the wheel down. If I move that coil away, because it's hooked up, it's gonna, there might not be a load on it, so it might not be lensing the wheel. But if I like plug it into the battery, if I plug the DC into the battery and start charging the battery, it's gonna lens the wheel. And it's immediately going to slow down. But right now, the only thing hooked up to the coil or the DC portal right here are the two multimeters. Without a doubt, there's going to be some loss. Now, I'm debating on whether it's like this coil on the outside here is enough to compensate for that minuscule loss that we're going to get. So, I'm going to hook up. I'm going to take the AC connections and I'm going to hook them to DSSG output. We're going to see exactly how much output we're getting. It's kind of like a transformer, I would say. This coil on the outside. The mechanical energy. All right, so what we want to do is we want to switch this over to DC. Okay, that's kind of weird. Let's turn it on. So we're at 12.46 in with 380 milliamps max, and that's how much we're getting out of the output. It's a little less, exactly a little less, like almost a little less than a volt. But then again, this cap bank has got 73 volts in it from the AC generator. It's pretty smooth. I mean, that's exactly how I would explain it. That you're gonna have a loss for your diodes, your resistors, your transistor. You got resistance in the coils. I had tried to minimize that by using larger gauges or smaller gauges, thicker wire. Works pretty good. Um, yeah. Thank you very much, Ken. Heck yeah, man. Those are fast. The outrunner motors are fast. Wow, you getting mad mad numbers off that, I would assume. All right, that's with 2 magnets, ladies and gentlemen. We're gonna put 9 magnets back up there and get some readings off of them. Yeah, I got a few computer fan motor thing. I had a whole setup with computer fan motors and little magnets and like a fence that I made out of wire. It was pretty weird, but it was cool. Because I got the pegboard with the holes in it, and 1/4 inch, and everything just kind of came off of that. That's why my shafts are 1/4 inch, because that's where I started. Oh, I'm getting better and better at that. All right, I think that'll work. Oh, wow, 60 amps, dude. Just thinking about that, you know, and that 60 is a lot, but it's not a lot. I think 60 is a lot, though. Now, we're getting about the same amount of output, definitely, from the SSG, which is good. And it looks like we're going to end up getting less from, we'll see. We're going to wait. There's a lot less fluctuation in the light, though. It's a different fluctuation. A lot more stable output with 9. $800. There's 110 amps or volts in the cat bank, and we're getting 12 point. Wow. Okay. But we're drawing 600 milliamps of current. Wow, that's freaking cool. I mean, when it gets going really fast, I mean, really, really fast, like faster than I can make it go right now, I can see those numbers getting better, you know? But it's got to be going really, really fast. Wow, I want to check another one, but it'd take a lot of, it's a 12 magnet, 12 pole rotor with a north-south configuration. And I mean, the magnets are right next to each other, so there's like no space between them. It's really neat, I think. This one right here. And then this one kind of pulls everything to the center and sucks it down through the center. So I put some uh, fabric softener on there. Yeah, let's try this one. Oh, that one right there, a little 120. But there's a magnet on the table right here, and those have got to be aligned the right way, or they're going to pop right out of there. So Hey, Yanni, what's up? Thank you. Thank you. I appreciate that. There's one right there. I got another one. Yeah, this one right here. All right, so the way we're going to find out if this is going to work, like right off the bat. So south in the middle, north, nice. So that'll work if we can get one of these stable. It's got to clamp down. I got to put this up for right now. So if you leave a comment, I will get to you as soon as I can. I'm just setting this up so that I can use that rotor. Yeah, that's all right. Now, here's it. All right. Now it should hold this down in place because it's a traction phase. That is freaking awesome. Wow, that is so smooth. Let's get some close-up footage of that. Amazing. So it's definitely spinning the other way that it looks like it's spinning. Wow, dude. That is going really, really fast. already going way more than 1,000. A lot of wind coming off of this one. 5,000 divided by 3. Oh yeah, thank you. Thank you, Ken. It means that I couldn't find a core that would fit. I printed one with iron infused PLA, but it doesn't fit. And I could make, I just don't have enough material right now. I put 4 ferrite rods in there in 2 inches. Like I did the other one. You can kind of see it right across the 4 rods in there. But yeah, you get a little bit more output. And when it's going really fast, I mean, that output is probably going to exceed or get really close to unity. But yeah, I got to cannibalize a couple of cords, and then I can hook up the one adjacent. And that would be super dope. Heck yeah, Yanni. It's good stuff. K Energy Store SSG combo. He made me a special one without a switch in it. So yeah, I'm gonna hook up. I'll do that real quick if I can find enough connections. Because I've been doing some exotic stuff with my connections. So I just gotta cannibalize what I've been doing to hook up the other one. All right, Ken, see you later, man. Appreciate you. Heck yeah, man. And I mean, the pulse motor circuit is a switch, a coil, and a power supply. And then you need a rotor of some kind. A rotor is where, a lot of ingenuity comes into play. But the circuit for a pulse motor it is right up my alley. No, man, it's real simple. You are that good. You are that good. Yeah, right on. Thank you. Thank you, guys. All right, I'm going to prop this up. See, like these big coils right here work better with the reed switch. They're single file, that's probably why there's no trigger coil embedded in there. That's a trifilar coil, so there's 3 strands in it. You got your drive, your trigger, and then you got your transformer strand. I like to call it the transformer strand. So we might get some readings off of the triggers, the transformer strand. My bad. All right, now all right, so let's turn it on. Let's see. No. Let's see here. I had a feeling. I don't think that'll work. I'm gonna put 2 resistors in this thing, like I did the other one. I'm gonna try and put it in there, but I don't think it's gonna fit like that. No, I'm not gonna waste my time with trying to squeeze them both in like that. So I'll clip them in, clip in the last one here. See, and this is how I gotta do it. Now I can do it like with the clips. Just a little bit of all right, now there should be a transistor, unless this is it. I think this is it. Let's turn it on real quick. Bingo. Power wire came out. Make sure that's in there right. I just hope I grab the right one. I gotta test all of these, make sure they're all really broken. I'll get around to doing that later. When I'm bored, I'll do it. Oh, the surgical revival. Wonder what the hell the problem is. I wonder if I should put the trifilar strand. That's what I'm going to do. I really don't like it when things don't work right. Well, I might have grabbed the wrong one. I put it down somewhere. If you want to leave a comment, I will get to it as soon as I can. For sure. Been a good day. Wow, I'm sweating. Dang. I mean, my cat got its tail caught in all this wire and now it doesn't work. So here, let me just tighten all this stuff. Yeah, I don't know. It might be the coil. I don't know what it is. Man. That's another specially made one that's SSG alone. It's not a combo. I tried running a relay with that one and this one, and it closed the circuit and it started smoking. So that might be, it might have fried it. This one still works though. That would have been sweet to have the dual drive though. That would have been nice. Trying to just see if I can look and see what shorting out everything. Because that's what's happening. It's getting shorted. Wow, this is still, it says 0.1 amps. It says 100 milliamps, 0 volts, and it's holy smoke. That's weird. That is weird. It's shorted out for sure. That's definitely what was going on. It was moving that fast with a shorted out coil on it. That's funny. It's actually a pretty good sign. If that's what you're into, is shorting out coils. It was running pretty good, actually. So did you all hear that? Like, see the change when I see this is off. This is all off. But when I complete the circuit, even though the power's off, and that's definitely because there's a short, and that's what the reading is. It's 100 milliamps. Well, that's what you get when you play with electricity, man. I think I fried this thing because it's shorted out. So now watch when I unclip this. You can hear it. Like, yeah. Oops. Oops. Oh man. So that one's broken. That sucks. I don't know what's wrong with it. I think maybe, I don't know. Because I just put two brand new transistors in it and it's shorted out. So it's probably not even going through the transistor. I don't know. Mm, so cool. Yeah, and the weird thing is I had the relay working, and the relay is 180-degree magnets on the rotor, and then a coil at 0 degrees and a coil at 90 degrees. And you're supposed to be able to do the relay without relays. And it worked. The first time I did it, it worked. It worked really good. There was a voltage drop on one battery of 0.5, but it worked after that. And they both started to climb for a while. But, it wasn't a stable system. And I wanted to make improvements on it. But when I went to go and try and hook it up again, I shorted out the circuit. I think the difference is that the first time it was already running, like one coil was already on, and then I turned on the other coil. And the second time I tried to start it all at once, and it shorted out. Tried to have everything hooked up already and then start it, and it fried that way. It's not a good way to do it. I don't know why. That's the way you're trained to do it. That's the way you're supposed to do it. You're supposed to hook up all the wires first and then start it. But it fried it. And it worked better when I had the coil, and then I just clipped everything on there after the fact. Mm. I might try that again, but it's going to be a while. I might have to learn how to make an SSG circuit if I'm going to be shorting them out like this. All right. I think this is awesome. But I'm going to take it easy for a minute. Thank you very much, ladies and gentlemen, for coming in. I'm probably going to do this maybe once a week now, maybe more. I'm going to try and get something new in every time. I'm going to try and keep it pulse motor style. I might incorporate new things like different coils and stuff. Tesla coils, vortex coils, geometric coils, all different kinds of coils. And over time, they're going to show up on the channel. I'm just letting you know. Look at that pyramid, man. That's pretty sweet. It's plastic, but it's sweet. I got this one too. It's pretty nice. All right. Well, thank you very much. Peace out. Have a wonderful day. Bye now. See you, Yanni.